Okay, now this will be the second part. In the original video couldn't cover problem 6, so here we go. In problem 6, as you already heard, if you read and watched the video, now it's asking us that it's asking us about the two hosts A and B, since it begins with propagation delay and transmission delay with the two central concepts, and A and B are connected by a single link of 8 bits per second. Now, they're asking if the two holes are separated by a meter. If the total propagation speed along the link is s meters slash second. Hold A to send a packet of size L bits to host. Now, for in A, they're asking for the propagation delay in terms of ms per m and s. So, the reason us giving us how should we start our equation would be dprop. So, propagation delay would be dprop equal m slash s second. Now, for part B, determine the transmission time of the packet dtrans in terms of L and R. So for that, it also given us the equation as well. It will be transmission time will be dtrans equal LR second. Now, C. Ignoring processing queuing delay, obtain an expression for the end-to-end delay. Now, that end-to-end delay for the expression, they're asking us, like, this is a mixture between the propagation delay and transmission time. So they wanted to add those two equations. So for this would be, instead of using dprop dtrans, we'll be using total time equals LOR plus ms second. Now for D, we have to solve it on our own, which I did that using a calculator and some notebooks to complete the equation. Now, let me read D for you. Suppose host A begin to transmit the packet at time t equals 0. At time t equals dtrans, where's the last bit of the packet? Oh, no, not, no, sorry. That equation, I'm sorry, I mixed it up. Okay, that would be in the G final, not in D. Okay, now they're given the whole question now. T is equal to 0 and t equal to dtrans. So basically, the last bit of the packet will be you have t equal to dtrans, since that will be your equation equaling to. Okay, now let's go to E. Suppose dprop is greater than dtrans. At time t equal dtrans, where's the first bit of the packet? Now they're asking us where's the first, and here it is giving us the answer. So dprop is greater than dtrans. So the first bit of the packet will be dprop equal dtrans, basically on that equation. Now, for F and G, these are the two final. Okay, now let's read F. Suppose the part less than dtrans at time t equal dtrans. Where's the first spin impact? Okay. Hold up. I had a signal error, and I had to fix it on it. Okay, so they're giving us the answer in F. So then the first bit of bracket will be there to write dprop is less than dtrans. Okay, now for G, this is when we solve it. So they're giving us, suppose S equals 2.5 times 10 to the power 8, L equals 120 bits per second, and R equals 56 kilo. Find the distance so that dprop equals dtrans. Okay, now, how can we find dprop and dtrans? Oh, it's so simple. Let's go back to 6. So dprop will be ms m over s second, and dtrans will be L over R second if you know. Okay. And then here they're giving us on how we could solve it. And we're trying to find M, which would be in the, how should I say, in the dprop section, I believe. Okay, so right here, what can we do? So we write L over R for the trans, which will be 120 divided by 56. From like the polygon to 10, now this will be in the trans section right over here, and for the primary it will be m over s, which is 2m divided by 2.5 times 10 to the power 8. Now we don't know what is m, so we have to find out. Now for that, once you divide this, you get from 120 divided by 50, you get 2.142857. Okay, but we're not done yet. So in the S section, we need to do 10 to the power of 8. And 10 to the power of 8 will be 100,000. Oh, wait. And then if you multiply that by 2.5, you get 250,000. And then you multiply that by 2.1428 with the number that I told you about. 1428. Then you get 535 down 700. 535 down 700,000. Okay, but then you need to divide those by 1,000, and you get a 575 and 700, and you divide that by another 1,000. And you get 535.7. So then that will be for the result m, but then how we cannot enter like a decimal number. So then for the kilometer, we round up the 5 into a 6. So then it will be 536 kilometers, the distance for m. So thank you, folks. You have a good day.